Hi guys, it's me Udav Saraswat. Welcome to another video of my channel. And in this video, we are going to look into Docker. Okay, so nowadays Docker, Kubernetes, these are in top trending techs right now. So what Docker is and how we can install Docker in our Windows system and how we can use that and do run the basic commands. So that is what today we are going to look into. So Docker is basically a platform where we can develop and run our applications. So Docker consists of containers and images. So if let's say we created a Spring Boot application and or any application using plans and anything, we are having a something like jar file for a Spring Boot application, for example. So that jar file will be having some dependencies. Okay, so first dependency is Java itself. Okay, so Java is required for application to that jar file to run. So Java is one dependency, and let's say you were using Maven and you added lot more dependencies as well, such as Spring Web. All those dependencies you also added. So those also needs to be clubbed into that particular image which we are going to create using Docker, so that it can be deployed in any container. It can run anywhere. So the concept of Docker is that one we created one container of one image of that application, and that image will contain every dependency, everything required to run that application. Okay, and that image we created can be deployed to anywhere, to any of the containers or in the servers directly. So the problem that was that earlier faced, like you when we are creating an application, then directly deploying it to servers, then doing configuration one by one, getting dependencies, sometimes the dependencies are not getting downloaded. All those issues were the industries were facing earlier. So those issues are now, we can say, very much eased using this Docker system. So what is going to happen is, we this Docker provides us that particular functionality. Okay, so Docker is having a concept of containers. So inside Docker, I will show you an image. In this image, it will be clear from using this image. So what Docker is, Docker basically has three particular components inside that. First one is client, second one is server, and third one is repository. So first one, let's talk about the first one, client. So client is you and me are the client. So we will be installing Docker desktop in a system later on in this video, and using that Docker desktop, we will be interacting with the Docker server. Okay, so we are the client. So this particular client, what it will be doing, so these three are the basic commands: docker build, docker pull, and docker run. So docker build will what it will do, so what Docker do, Docker creates images. So this docker build will create image for that particular jar application, for that application you want to create. And docker pull is, so you might have pushed some image to this Docker earlier, and right now you want to get that back into your system. You deleted it for some cause, now you want to get that back, so you will do docker pull. So it will pull from those repository, it will get that image back and store it on your local. Docker run is, it will run the Docker script. So we can have a Docker script in our application. Okay, so it will run that. So using that, we can run our application or configure things which needs to be configured before even the application runs. So those are things we can do. In the server side, we are having a daemon process. So daemon, what is daemon process? Daemon process is the main process. Okay, so this is the main process. We, our commands will be coming directly to this particular daemon process, and this daemon process internally manages multiple processes. Okay, you can consider this daemon process as the daemon thread. Okay, inside it will be having multiple threads which it will manage. Okay, so inside that, so what this daemon process will manage, it will manage container and images. So images are the what we saw, the project we created. So the images are of those projects which we created. We created an image, we pull, we created a project, we created an image for that, we pushed it to the repository. Okay, so that image we created, that will daemon process will manage that particular image. Okay, it will create that and will push to repository. So creation process will be done by daemon thread itself. So it will create a new thread for that particular request. And containerization. So what containerization is, that particular image we will be put into a container with other things as well. Okay, all the dependencies, everything will be put into that particular one container. So like that, this server will be handling these requests. Container management and image management will be done by this server and daemon process. and this repository is for saving. Okay, so once your image is created, you will have to, like, we use Git and GitHub for our source code management. Like that, we will be having different images for our project as well. Okay, so one image you create today, and tomorrow you did one more development, and now you want to create a new image, but you don't want to delete the older image because you want to keep it for further use as well. If your new features break or something happens, you want a backup in that case as well. So we want a new image to be stored into the repository. So this is what this repository manages. All our new images will be like version 0.0.1, 0.0.2, like that. Images will be version and stored in the repository itself. And whenever we will do Docker pull, it will pull from those images only. Okay, this is how this Docker system works. And inside that, we are having, so what we can use Docker for. So let us just go by these points one by one in brief. So fast and consistent delivery of our applications. So as we discussed, all the images are containerized, all the dependencies are there in the one container. You can take that container anywhere and you can just deploy that. So it is not going to fail, nothing is going to happen, because all the things are by default is there in in that container, which are required for that application to work. So that point is also covered. Okay, and second one is responsive deployment and scaling. So using Kubernetes also we can do that. So, or scaling we can do. So let's say your application, you created one application. Okay, you create an image for that, you create a container and you deployed that in a one server. And let's say the load increased, you expected 100 users will access that application, and now 200 comes. So in that case, you want to, what is the requirement is that you need to duplicate that Docker container. Like instead of one, two needs to run in this case. Okay, so that can also be done using Docker is having a system. It can duplicate that particular container if a particular threshold is breached. Okay, that particular function is also available. Okay, so it is lightweight and fast, so it will support more workloads. And this is the architecture: client, server, and repository, which we just discussed in the other diagram. Okay, Docker daemon we have discussed. This is the main thread which runs in the server and manages the sub processes and sub threads. Docker client is nothing but the Docker desktop, or we will be interacting with using that Docker desktop with the Docker server to carry out the tasks such as Docker run, Docker build. All those tasks we will be executing using Docker client. Docker desktop. Okay, so Docker desktop is nothing but a Docker client, and for Windows system or Mac system, we can download Docker desktop and interact with the Docker server directly. Otherwise, Docker is accessed by a Linux system only. But using Docker desktop from Windows system itself, we can access that. And Docker registries. So every Docker registry is the one which stores the Docker images. So all the images we are doing when we do Docker pull, so all that registry will create a ID for that particular image. A unique ID will be created for the image we are pushing to Docker repository, and that ID generation and storage will be done by this Docker registries. It will register, okay, for this application, this is the ID which we generated, and when someone is telling me Docker pull, then this particular ID image needs to be pulled. Okay, those all things are internally handled by this Docker registries. Docker object, anything we are creating is a Docker object. Images, container, networks, volume, anything what we are doing. Containers are also Docker objects, and images, as we discussed just now, images are the, once we create a project, we that project will be running in a Linux system or some system. Those all things combined together is called a image. Okay, so image and containers, we have seen containers is enable instance of an image. So that image we have created, we will create a container out of that, so the container will be running that image inside that. Okay, so and we can interact with the container itself. So that is what it is. And after that, okay, so Docker is built on Go programming language. So this is also one part. If you are interested in learning uh, to contribute in an open source system such as Docker or Kubernetes, so Go programming language is most widely used in cloud-related technologies such as Docker or cloud as well. Cloud such as cloud services also are done in Go programming language. Kubernetes, everywhere you will see this Go programming language. You can learn that as well if you want to contribute to open source systems which are having Docker and Kubernetes involved in them. Okay. Okay, that's it, guys, for for today's session. Let's see you in the next session. Till then, happy learning.